Okay, so in this video, we're looking at quadratic sequences. So a quadratic sequence is similar enough to a linear sequence, but the first difference is not the same. But however, the second difference is. So a quadratic sequence is a sequence where the second difference is constant. So if we look at this term sequence here, 7, 8, 12, 19. We see the first difference is 1, 4, 7. That doesn't make it linear. We know what that is. But if we look at the second difference, the difference between 1 and 4 is 3. 4 and 7 is 3. So the second distance is constant. So the general form of a quadratic sequence is Tn is equal to an squared plus bn plus c. So this looks like our general quadratic form. Like, ax squared plus bx plus c. So it looks like that. So what's really important to note is, for a quadratic sequence, a, or the coefficient of n squared here, is going to be half my second difference. Always half my second difference. So we want to be able to find the nth term of a quadratic sequence. So how do we do that? So first of all, we find the second difference. We find the value of a by halving it and subbing it into our formula. Then we do what we do. When we're finding a and d of our arithmetic sequence, right? We want to sub in n as 1 and sub in t1, or so we want to sub in n as 1 and the first term and get an equation for b and c, and then do the same thing, sub in like n as 2 and the second term and get an equation for b and c. Solve them simultaneously to find b and c, and then sub them all back in to our original expression. So find Tn, the nth term for the following quadratic sequence: 13, 17, 29, 49, etc. So 13, 17, 29, 49. So this is going to be 4, 12, and 20. But if you look here, my second difference is 8. So it's a quadratic sequence. My second difference is constant. So a is equal to half my second difference. So a is equal to half of 8. A is equal to 4. So I'm going to have here Tn is equal to 4n squared plus bn plus c. So let's sub in some values here. I'm going to sub in n equals 1 and t1. And t1, or my first term, is 13. So I'm going to have 13 is equal to 4 times 1 squared plus b times 1 plus c. So 13 is equal to 4 plus b plus c. B plus c is equal to 9. That's my first equation. Let's open my second one. Let's say n is 2. And then t2, when n is 2, tn is going to be equal to 17. So I'm going to have 17 is equal to 4 times 2 squared plus b times 2 plus c. 17 equals 4 times 4, because 2 squared is 4, plus 2b plus c. 17 is equal to 16 plus 2b plus c. My second equation is 2b plus c is equal to 1. So now I have two equations in b and c. Now I need to solve these simultaneously to get b and c. So b plus c is equal to 9. 2b plus c is equal to 1. I'm just going to multiply the top here by minus 1. I want to cancel out the c's. So minus b minus c minus 9. Add them up. I'm going to get b. So 2b minus b is b. Minus c plus c is 0. Minus 9 plus 1 is minus 8. So b is equal to minus 8. Sub in to get c. So minus 8 plus c is equal to 9. C is going to be equal to 17. Good. C is going to be equal to 17. So therefore, my quadratic sequence, so an squared plus bn plus c, the nth term is going to be 4n squared minus 8n plus 17. Right, and that is my general term there. Right, so let's look at some exam questions now. So let's look at this exam style question. So the first 4 terms of quadratic sequence are as follows. What is the formula for the nth term? So 7, 11, and 15. So I'm going up in 4s. So my second difference is 4, so it's quadratic. A then is going to be equal to 2. So I have Tn is equal to 2n squared plus bn plus c. So when n equals 1, Tn equals 3. So 3 is equal to 2 times 1 squared plus b times 1 plus c. 3 is equal to 2 plus b plus c. B plus c is equal to 1. That's my first equation there. My second equation, n equals 2. Tn is equal to 10. 10 is equal to 2 times 2 squared plus b times 2 plus c. 10 is equal to 2 times 4 because 2 squared is 4. It's going to be 8 plus 2b plus c. 2b plus c is equal to 2. And that is my second equation. Solve these simultaneously. Going to multiply the top here by minus 1. Minus b minus c minus 1. Add them up. I'm going to get b is equal to 1. And b is equal to 1. B plus c is equal to 1. 1 plus c is equal to 1. Then b is 1. Therefore c is 0. So I have a, I have b, I have c. Therefore Tn is equal to 2n squared plus bn, which is 1 times n, which is just n. Alright, let's look at another one here. So the distance of a ball travels after being thrown every second is 10 meters, 18 meters, 28 meters, 40 meters, 54 meters. Assume that the ball continues to travel at the same rate. How far will it travel in the 7th second? So 10, 18, 28, 40, 54. So 8, 10, 12, 14. No, but my second difference is 2. So my second difference is 2. Therefore, A is going to equal a half of 2. A is equal to 1. So therefore, Tn is equal to n squared plus bn plus c. When n equals 1, Tn is equal to 10. So 10 is equal to 1 squared plus b times 1 plus c. 10 is equal to 1 plus b plus c. B plus c is equal to 9. Right? And n equals 2. Tn is equal to 18. So my second term is 18. 18 equals 2 squared plus b times 2 plus c. 18 equals 14 plus 2b plus c. 2b plus c is going to be equal to 4. So there's my second equation. Solve these simultaneously now. Multiply the top by minus 1, minus b, minus c, minus 9. B equals minus 5. And sub it in. Minus 5 plus c is equal to 9. C is going to be equal to 14. So Tn is equal to n squared minus 5n plus 14. Right. Let's look at some now, like proper exam questions. So this is from the genes here from 2015. So these triangles can be put in a sequence of increasing size. The lengths of the bases of the triangles follow a quadratic pattern. The 3 consecutive triangles in the sequence are shown below. Use this information to find the length of the base of the next triangle in the sequence. So these follow a quadratic pattern. They're telling me it follows a quadratic pattern. So 84, 112, 144. So the first difference here is 28. And then the difference here is 32. And the second difference then is going to be 4. So we know it's a quadratic pattern. So therefore, 4 plus 32 is 36 because it told me it is. And then 144 plus 36 is 180. Therefore, the answer is 180. Right, the length of the hypotenuse h of triangle x in the sequence is given by this function. H of 1 is 5, h of 2 is 13. Use this information to write two equations in B and C. So when x equals 1, h equals 5, okay? So 5 equals 2 times 1 squared plus b times 1 plus c. 5 equals 2 plus b plus c. So my first equation here, actually let me move all this over. That's got to be b plus c is equal to 3. Second one here, I'm going to have h of 2 is equal to 13. So 13 is going to equal to 2 times 2 squared plus b times 2 plus c. So when x equals 2, h is equal to 13. 13 equals 2 times 2 squared is going to be 8 plus 2b plus c. So a second equation is going to be 2b plus c is equal to 5. Now it's asked me to solve these simultaneously to find the value of b and c. So b plus c is equal to 3. 2b plus c is equal to 5. Top line by minus 1, minus b minus c minus 3. That's going to be b is equal to 2. Sub in, I have b plus c is equal to 3. 2 plus c is equal to 3. C is equal to 1. There we go. Right, another one here. Investigate where the pattern of the table is linear, quadratic, or exponential. Explain your conclusion. Well, looking here, let's look at the first difference. So I go, so 8a minus 2b plus 2c minus all this. So 8a minus 2a is 6a. Minus 2b minus negative b is going to be just minus b. And then 2c minus 2c, well, I'm not adding anything to the c's, so that's fine. Let's check now here. So I from get to 8a to 18a, I add 10a. Then we get from minus 2b to minus 3b, I subtract b, and 2c, leave it as it is. Term 3 to 4. So 18a to 32a, that is 14a minus b. And then here, 32a up to 50a is 18a. And then minus 4b to minus 5b is minus b. Let's look at the second difference now. Because my first difference here is not the same, so it's definitely not linear. So how do I get from 6a to 10a? Well, I add 4a. How do I get from minus b to minus b? Well, I add nothing. 10a to 14a, I add 4a. Minus b to minus b, I add nothing. So we notice here I have a second my second difference is common. So same. So this pattern is quadratic as second difference is the same. Right. Then let's look at one more question here. So this is from the Leaving Cert higher level. So shapes in the form of small equilateral triangles can be made using matchsticks of equal length. These shapes can be put together in patterns. The beginning of the sequence, these patterns are shown. Draw the fourth pattern in this sequence. So I need to draw the fourth one. So I have one triangle on top, 3 at the side. Ding, 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 ding. There you go. Fourth pattern there. The number of matchsticks in the nth pattern is represented by the function un equals an squared plus bn, where a, b is an element of rational numbers and n is a natural number. Find the value of a and b. So this is just a function for the number of matchsticks in this. So I use 3 matchsticks in my first term. So when n equals 1, un, I suppose, is equal to 3. So I have 3 is equal to a times 1 squared plus b times 1. 3 is equal to a plus b. Gorge. First equation. Second equation, when n is equal to 2, number of matchsticks is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to have 9 is equal to 2 times 2 squared plus b times 2. 9 is equal to 8 plus 2. Oh, sorry, did I say 2 here? So I went a. So 4a plus b plus 2b is equal to 9. So a plus b is equal to 3. 4a plus 2b is equal to 9. I'm going to multiply the top here by minus 2. I'm going to cancel out the b's. That's going to be minus 2a, minus 2b, minus 6. Add these up. I'm going to get 2a is equal to 3. A is equal to 3 over 2. A is equal to 3 over 2. Sub it in. 3 over 2 plus b is equal to 3. B is equal to... B is equal to... So 1.5 plus b is equal to 3. So b is going to be equal to 3.5. 3 over 2 or 1.5 as well. Finally, right now for the last question, one of the patterns and sequences have 4,134 matchsticks. How many small triangles are in that pattern? So what we're going to do is we're going to find out which term has the which term has 4,134 matchsticks. So I'm going to use my answer from B. So we have un is equal to 3 over 2n squared plus 3 over 2n. I'm going to let that equal 4,134. Multiply or divide both sides by 3 over 2. I'm going to get n squared plus n is equal to 4,134 divided by 1.5 is 2756. I'm going to have a quadratic here. This factors out, so n plus 53, n minus 52 equals 0. So you're going to have n is equal to minus 53, n is equal to 52. So I can't have n is minus 53 because it's negative. So in the 54th term, I have that many patterns. But now you need to find out how many triangles are in the 52nd pattern. So if I look here at the number of triangles, see if it follows any pattern here. Well, I have 1 triangle in this one, 4. Then I have 9. Do we notice anything here? Well, it is my term number squared. 1 squared is 1, 2 squared is 4, 3 squared is 9. So I'm going to say Tn equals n squared. So Tn is the number of triangles, right? So T52 is equal to 52 squared. Therefore, in the 52nd pattern, there are 2,704 triangles in the pattern. Right? And that's the last question there. I hope this video was some help to you guys, and I'll catch you guys later. Bye.